We've talked about ionic bonds so far, so today we're going to be talking about covalent bonds. So ionic bonds are between a metal and a nonmetal, and covalent bonds that we're looking at today are between two nonmetals typically. Think about your periodic table for a sec, and think about, we talked about valence electrons and how the ones towards the left side, where you have group 1, group 2, they have only a few valence electrons. Whereas as you go further right, you have more valence electrons because, group 16 has 6, group 17 has 7, 18 has 8. So we're getting to where we have more valence electrons. So if we have two nonmetals that are bonding together, which are on the right side of that table, it's a lot easier for them to just share those valence electrons. It takes a lot less energy for that because they have almost full shells anyways. So both of them would have to give somebody's going to have to give some up, and it takes a lot less energy for them if they just share them together. So that's why two nonmetals typically form our covalent bonds. If you have anything containing a covalent bond, that compound is called a molecule. So when we say molecule, we're specifically talking about compounds that are formed with covalent bonds. And again, as any compound does, they form in a specific ratio. So a molecule that has just two atoms are called diatomic molecules. So di means two, atomic, atom, so two atoms of that same element. So the elements that are found in nature that are diatomic are called diatomic elements specifically. So hydrogen exists as a diatomic element in nature. It exists as H2. Oxygen exists as O2. Nitrogen exists as N2. All of the halogens, everything in group 17, remember we say they're super reactive. So they're so reactive that they exist only as diatomic molecules in nature. So chlorine, iodine, they all exist as Cl2 or I2 in nature because they react so readily that they're always going to be paired up with themselves. So if you are listening, I want you to write down H2 next to hydrogen, O2 next to oxygen, and N2 next to nitrogen on these notes. So H2, O2, and N2. So I know you're listening. That'll be for full credit. And also with these molecules, they can be really simple as O2, or they can be really complex, where we have things like glucose, that's C6H12O6. So it just depends on what we're looking at. And last thing, we're going to get more into this in the next couple of lessons, but there's something called polarity in molecules. And you have some molecules that are polar and some that are nonpolar. So our polar molecules are the ones that they don't share those electrons evenly. So the electrons are being pulled a little bit more towards one of the atoms than the other because it has a higher electronegativity. And again, we'll get into this a little more in detail, but nonpolar is when you have the electrons being shared equally, so that neither atom is pulling harder than the other one, so they're shared right in the middle of those atoms.